Assalamualaikum and hello everyone. Welcome back to the video of 2.1 Bohr's atomic model. So last week we have looked at a lot of our content in 2.1 itself. Okay, so before we're going to move further into the new learning outcome. So first what I'm going to do is I'm going to do a bit of recap of what we have learned previously. Okay, so we have learned, first and foremost, we have learned about the Bohr's atomic model, and there are actually 4 postulates. Okay, but then from the postulate itself, first we have learned there are actually formula used to calculate the energy of the electron located at a specific shell ataupun specific energy level, where this is actually the first formula that we encounter, which you have to memorize. Okay, and then we have also looked at the second formula, which is delta E ni. Is the second formula that we have learned. Is actually when the electron move from a higher energy level to a lower energy level, it will emit a specific amount of energy in the form of light or photon, where it could be calculated. Okay, and then, so that's the second formula. The third formula that you should be able to memorize and able to use in your example, is actually delta E is equal to HV, and delta E is equal to HC over lambda. As we have mentioned before, when the energy emitted in the form of light or photon, there are actually a specific wavelength or frequency associated. So we can use based on this formula lah. Okay, so there are actually the 4 formula that you have to memorize by the end yang page 3 ni, by the end of the examples on page 3. Okay, after that, we have learned about actually the formation of line spectrum. Okay, the formation of line spectrum ni is actually based on the Bohr's atomic postulate number 3 and 4. Okay, so if the question did ask you about the formation of line spectrum, make sure this about this part. Okay, this is your energy level diagram. Depends, but the question seldomly asks about the energy level diagram lah. This is actually in terms of words there. This is in terms of diagram there itself. But actually, during the question, if the question they ask you, so you have to explain it in terms of words. Okay, so after we have learned about the formation of line spectrum, then we learn about there are actually 5 different spectral series. Okay, and then each of the different spectral series ni ada different ground state yang default to which n ataupun specific n tu energy level kita lah. So it's actually Lyman, Balmer, Paschen, Brackett, Pfund. Okay, ataupun ada 2 tips lah. 5 baby pergi beli pampers, or Lyman balik pasar, break ke bra putus. So up to you which one you're comfortable with. Just to make sure, yang itu sebenarnya tips for you to remember what is actually the ground state for the given series. And then you also must know about the spectrum region itself. So spectrum region ni, Lyman is actually ultraviolet, Balmer is visible, Paschen, Brackett, Pfund, infrared. Okay, so sometimes visible region ni does not mention specifically this is a visible region, does not. Sometimes dia kata this region produce green, blue, red light, macam tu. So it is actually your Balmer series, visible yang kita nampak. So kita boleh nampak kan the red, blue and pink color, any color lah. Okay, and besides that, you must be able to know what is actually, for example, dia bagi second line of a Paschen series. So you must be able to know lah what is actually the excited state, the higher energy level, and what is actually the ground state. The ground state too, it depends on our series, line series. Okay. So what we're gonna learn next is actually okay. Why I mention yang ini important? Because later on, later examples that we're going to look, dia kata calculate the energy of second line of Balmer, calculate the wavelength of the fourth line of Brackett series, macam tu lah. So you must be able to know what is actually the energy, the excited state, and what is actually the ground state. Okay, and then yang this part is actually yang ini paling penting is for you to know for a given line spectrum. Okay, kalau first line ni contohnya for a given line spectrum, dia mesti ada 1n dengan 1n. It does not mean that kalau on your right hand side tu it must be first line, does not. So, how to determine the first line on the series itself? Tengok yang mana biggest gap. So, dalam case ni, biggest gap kita is between these two lines. So, this is actually my first line. For this part, biggest gap dia actually between this one. So, this is actually my first line. So, yang itulah yang importantnya. Okay, next, what we're gonna learn. Yang ini yang baru. Yang itu is just a recap what we have learned last week. Takut kamu pun lupa dah apa. Apa yang dah belajar? Tak ingat. Tahu, tak faham je. Itu. Bukanlah tak faham. You need sometimes for you to understand. Okay. So, for this week, apa yang kita akan belajar atau in this video, we're gonna look at is actually a Rydberg equation. Okay. So, Rydberg equation ni is used for what? So, dia kata dekat sini, the wavelength emitted by the transition of electron is calculated by using the Rydberg equation. Okay, so we know that when electrons fall from a higher energy level to lower energy level, then they're going to produce light, okay, ataupun produce energy in the form of light or photon. And actually, the wavelength can be calculated. Sebenarnya wavelength tu kita boleh calculate delta E equal to Hc over lambda. Okay, and another way of calculating the wavelength straight away, ni satu step sahaja. Is 1 over wavelength. So, this is what we call our wave number lah. This is our wave number equal to RH. Okay. This case, Rydberg constant kita is 1.097 exponent 7 per meter. Okay, before this, what we have used is actually RH kita yang ni. 2.18 exponent negative 18 joule. So, kalau joule ni is used for the Rydberg constant in calculating the delta E. But then, kalau untuk the wavelength, okay, ataupun yang wave number kita ni, yang formula dia yang wave number kita ni, is actually per meter dekat sini. So, make sure lah. Okay, again, for this two value, you don't have to memorize. It is given in your list of constant. So, kena tengok, make sure kamu nak guna yang delta E ke, nak cari yang wavelength. Kalau wavelength, you have to use this unit, this value. And we're going to find out the delta E is this value. Okay, so itu yang lain dia sikit. And it's actually 1 over N1 squared minus 1 over N2 squared. Sebelum ni kita guna yang initial minus final kan. Yang kat sini, yang ni N1 minus N2. Where in this case, N1 ni is the lowest energy level. Lowest energy level ni which is our ground state jugalah. Ataupun ground state. This is actually our This is actually our ground state. This is actually our excited state. Okay, in this case, and then N1 must be smaller than N2. Ataupun pening lah nak buat macam ni. N2 must be bigger than N1. Contohnya kalau kita ada the ground state is 1, excited state dia 3. So, dekat sini yang 1 squared, sini yang 3 squared. So, dia lain sikit dekat sini lah. So, kalau kamu tak nak confuse, later when we're going to do the calculation, I'm going to emphasize to you which one N1, which one is our N2. Okay, so this is actually the formula that we're going to learn. The new formula. So, this is actually the fifth formula lah. Okay. Okay, again, yang dekat sini, this is actually, it's just a note for you. The different values of RH, which is your Rydberg constant, and its usage. Where previously, during the postulate 4 that we have learned, the delta E is equal to ni, Rydberg constant. So, it's in, when we are talking about energy, so yang ini unit dia joule lah. Okay, which is Rydberg constant, 1 over ni, initial squared minus final squared. 1 over initial squared minus 1 over final squared. Yang ini sebab tu mesti nak guna N1, N2 ni. Nanti kamu pun pening. Yang ini pun N1, N2. Tapi ni N1 must be bigger. This one N1 must be smaller. Okay, up to you lah which one yang kamu selesa. Ni suka tu lagi. Okay, and then that is for the first one. Rydberg constant yang baru saja Miss introduce tadi. Here is actually when we calculating the wavelength. Ataupun besok yang ni, wave number equal to RH. 1 over N1 squared minus 1 over N2 squared. Okay, so kita belajar 1, 2, 3, 4. Yang ini pun kita dah belajar dah. The examples in page 3. Okay, where V, remember V is equal to C over lambda. Kat sini cuma satu je formula yang tak ada. Bolehlah tulis kalau nak, kalau tak nak pun tak apa. the energy for a specific energy level, the energy of electron at specific energy level is equal to negative negative RH 1 over n squared. Okay, so tu pun ada lah. Okay, so without further ado, let's look straight to the questions. Okay, so now let's look for example number 1. So they ask for the wavelength of the first line in Balmer series. So Balmer series, what is actually our ground state? So ingat, Lyman balik pasal berapa tu? So dia adalah yang balik kan? So it's actually n equal to 2. Okay, so what is actually the first line in Balmer series? So yang ini means just briefly draw our energy level diagram. Okay, so the first possibility is from n equal to 3 to n equal to 2. So tu adalah first line kita lah. Nanti kita boleh tengok second line, third line kita. So here, we just tulis kat tepi ni. Okay, first line is actually n equal to 3 until n equal to 2. So this is actually what the question wants. Tapi yang ni sengaja je mesti tambah sikit lagi. So kalau second line, 4 to 2. Kalau third line, it's actually 5 to 2. That is our excited state. Kalau ataupun senang cara lain lagi, tambahkan number of line plus ground state. Okay, so sekarang ni, nak cari yang wavelength tu, based on the formula itself, we have to know that n2 must be bigger than n1. Okay, so kita tengoklah mana yang lagi bigger, which is n equal to 3. So n2 kita is actually 3, n1 kita is 2. Macam pening pula nombor ni kan. Tapi make sure remember lah, n2 must be bigger than n1. So yang ini Miss awal-awal dah labelkan itself. So this is actually the formula. And then supaya nak ingat, n2 is bigger than n1. Case ni Rydberg constant kita is actually 1.097 exponent 7 because it's actually about our meter, about our wavelength. Okay, and then 1 over, remember the n1 must be smaller. So which one is smaller is 2 squared minus 1 over 3 squared. So here we get our wavelength itself is yang ini just nak remind you again lah which one is bigger, which one is smaller. So we do get our, this is not our wavelength yet, this is actually our wave number. It's 1523611. Okay, so we have to make sure we want the wavelength itself. So the wavelength itself we get 6.56 exponent negative 7 molar pula meter. Okay, so wavelength sometimes the question minta in nanometer. Nano tu sebenarnya exponent negative 9. So yang ni Miss sengaja je buat extra step sikit sebab yang ni pun sebenarnya question for example number 2. So sebenarnya kalau dia tak bagi apa-apa, dua-dua dia terima. Sama ada exponent negative 7 ataupun bagi tahu in nanometer. Example 2 itself, I believe you could try it yourself. Yang ini tapi dia nak specific in nanometer. Okay, question 3. Calculate the frequency. So frequency ni, what is actually our frequency? It's actually V of the second line in Lyman series. So remember, Lyman balik pasal berapa tu? Dia Lyman. So n equal to 1. Okay, tapi dia kata the second line. The second line tu, kalau Lyman series, first possibility kita, yang mana? First possibility n equal to 2 to n equal to 1. Ingatlah yang itu yang first line. So second line tambahkan lagi n tu. So kat sini pun Miss tulis lah. First line apa, second line apa, third line apa. Yang ini biar kalau even though question us, bagi je lebih sikit pun tak apa. Yang ni just untuk kita je lah kan. Okay. Next is actually, terbalik. Sebenarnya ni excited state to ground state. Okay. So sekarang ni question talking about the second line in Lyman series. Okay. Dia nak frequency. Tapi ni is actually about our wavelength. So how do we find our frequency? Sebenarnya there are two methods to find our frequency. Okay, so the first one is actually, satu kamu boleh cari from, the first one, cari delta E dulu, then you're going to find our frequency. Or the second method, from the 1 over the Rydberg equation, then carilah V equal C over lambda. So there are two methods, but for this case, I'm going to do both. Tengok mana satu kamu selesa. Dua-dua akan dapat jawapan yang sama jugalah. Okay, tapi make sure tengok sampai habis supaya kamu tahu betul-betul yang mana kamu lagi, which one you're comfortable with. Okay, so yang ni first method and the second method. So first I'm gonna do yang delta E dulu. Okay, so for the delta E, remember the formula is actually delta E is equal to RH 1 over kat sini, ada formula kat sini, 1 over initial minus 1 over final. Okay, make sure RH kita tu adalah 2.18 exponent negative 18. So we're talking about energy kan. So dia nak yang in joule tu lah. Okay, so initial minus final. Okay, initial tu is actually our energy, yang high energy level tu before the drop. Final tu dia punya ground state itself. Okay, so delta E kita, remember RH tu is our yang Rydberg constant for joule. Initial kita, okay, we're talking about second line kan. So second line is actually 1/3 squared minus 1/1 squared. So we do get delta E is negative 1.9377 exponent negative 18. Okay, so negative ni sebab kita attraction ataupun nak bagi tahu the energy is released lah. Boleh lah nak tengok dua cara, nak tengok pun boleh juga. Nak kata energy is released. Okay, so next we're gonna find our frequency. So frequency is equal delta E is equal to HV. H is a constant, which is your Planck constant, 6.63 exponent negative 34. Okay, frequency tu kita tak tahu. But actually, both of these value will be a positive value. So sebenarnya kita punya delta E tu pun must be positive. Kalau walaupun negatif tu, remember it's actually about the attraction ataupun the energy release. Okay, so what happened here? Bila kamu masukkan the value itself, ignorekan the negative sign. So we do get our frequency. Okay, so what is actually the unit of frequency? Okay, kalau delta E is equal to joule. Kalau our Planck constant is actually joule per second. So maknanya kat sini frekuensi kita per second lah. Kalau time kan unit dia second, kalau frekuensi per second. Fizik pula tiba. Okay, so that is actually the first method. Okay, so the second method that we're gonna find out, just make sure yang ni delta E positive value. Second method ni pun senang juga. Mana-manalah kamu selesa. Okay, so dekat sini, cumanya dekat sini you have to make sure that yang RH tu again the one bukan 2.18, yang 1.097. Okay, yang itulah kena make sure. Kalau tak sure, tengok unit of our constant itself. Boleh tengok pada list of constant. Okay, yang kali ni remember, okay, we're talking about the second line where N2 must be bigger than N1. Maknanya dia nak nombor kecil tolak nombor besar. Okay, so N equal to 2 is N2. N equal to 1 is our N1. So kalau yang wavelength ni dia macam lain sikit tau. Dia memang nampak yang kecil tolak yang besar. So dia jadi 1/1 squared minus 1/3 squared. Kalau kamu tengok yang delta E tu dia macam 1/3 minus 3 squared 1/1 squared. So dia balik sikit lah dekat situ. So we get our wave number, then we're going to find out our wavelength. So after we find out our wavelength, we're not finished yet. What we're going to calculate is actually the frequency, which is equal frequency equal to C over lambda, where C is your speed of light. So V equal to C over lambda. So masukkan formula dulu. Okay, so V is equal to 3 exponent 8 divided by our wavelength 1.0255 exponent negative 7. So we do get 2.93 exponent 15 per second. Okay, so again, both of the method we're going to get the same answer. So up to you lah which one you're comfortable with. Cumanya nanti Miss nak buat pembahagi dulu, nanti Miss explain. Apa yang takut kamu confuse sikit lah. Okay, so for the first one ni, dia simple kan, senang lah. Maknanya kita tahu lah initial minus final. Dia straightforward. Cuma ingat ya, delta E tu bila cari our frequency, do not include our negative sign. So for the second one, equation ni, just make sure yang N tu must be bigger than N1. Yang lain semua dia quite straightforward. So example 4, I believe you could try yourself. Yang third line of bracket series tu, cubalah buat from what N to what N. So that's it.